Assalamualaikum and good morning. We are from Group 7. Today we are going to present our project which is about application of triple integral. This is our team members which consists of 4 people.
Hello, my name is Vimal, and now I'd like to explain about the problem statement, the idea of our project. Okay, and now the residents of Block D, Bumumbiru, at Taman University have been facing water shortage that has been a frequent issue in their area. The shortage is especially noticeable during the peak hours in the morning. This shortage not only interrupt the daily schedule, but also become a big problem for many students as they get ready for work and class. An individual dwelling in an apartment consumes around 90 liters of water each day, according to the World Health Organization, also known as WHO. However, it is subject to local characteristics of that building and the level of per capita usage, which thus number may go higher or lower. Inadequate storage capacity of the current water tank that may be incapable of providing for an increased population and their daily water needs is the primary source. Furthermore, if there are leaks in the plumbing system, the problem will become much worse because water that is wasted will not go to the taps. In order to solve this issue, the study will assess the amount of storage capacity required to satisfy the community increasing water needs. Triple integral will be used to calculate the water volume in the cylindrical water tank, allowing for precise sizing and design. By taking into consideration factors like population growth, demand trends, and possible leakage losses, this strategy will guarantee a steady supply of water in the future for the residents of Block D, Bumombiru, at Taman University.
Assalamualaikum. My name is Muhammad Amiruddin and I will continue about objective. So for this project, our group have determined three objectives. The first one is to understand and apply the concept of triple integral in cylindrical coordinate system to calculate the volume of water. The second one is to evaluate water usage requirement for residents based on WHO recommended daily consumption. And the last one is to calculate and compare the volume of water storage in the tank with the daily water requirement of residents using the triple integral method.
Okay, now let's move on to literature review. Okay, let me brief about the background of the project. So, water tanks are essential components of water supply systems, storing water for domestic, industrial, and commercial use. Water tanks is very important to regulate pressure and ensure reliability during peak times or emergencies. Okay. Tanks have their multiple uses. So based on their uses, uh, the materials will be made from like steel, concrete, or polyethylene, and it may be cylindrical, rectangular, or spherical in shape. So this study focuses on cylindrical tank with its volume calculated using triple integrals method in cylindrical coordinates for accurate results. Right now, WHO, or known as the World Health Organization, recommends about 90 liters of water per person per day for basic needs, including drinking, cooking, and sanitization. This requirement may increase in urban areas due to lifestyle differences, factors such as climate, household size, and infrastructure, which can also affect daily water demand. And the lack of sufficient water can impact health and hygiene. Let's continue. Residential water use depends on household size, plumbing system, and user habits. Peak demand typically occurs in the morning and evening, putting pressure on the system. In high-rise buildings, water tanks are critical to meet this demand, but poor maintenance or leaks can result up to 10% water loss, reducing usable supply. So, to ensure an adequate supply, the tank's storage capacity must match daily demand in the residential area. So, this study calculates the tank volume using triple integrals and convert the results to liters for comparison with daily needs. Reflects peak demand and future population growth uh, are also considered in this design. For this case, Block D of Bumbumiru has 20 units with 5 people each, totaling 100 residents. So this estimate helps to determine total daily demand with a safety margin added to account for changes in occupancy.
My name is Nur Nagisa Jua, so I'm going to talk about our methodology for this project. So for this project, we are going to use triple integral within spherical coordinate system because you want to provide a precise calculation for the volume of the current water tank. Because you want to determine whether the current water tank capacity is sufficient or not. If not, we will propose an improvement based on our calculation or any potential future demand. As you can see below, this is the equation for triple integral within spherical coordinate system. So we are going to proceed with the filler table. So the first fact is the resident of block D keep facing the water shortage, especially in the morning. So maybe the current water tank might be too small. So we need to resize the water tank. So the problem is here is how to calculate the volume using the triple integral in cylindrical coordinate. So we need to study and understand the triple integral so we can calculate the volume. For the second fact, the water tank has an overall height of 3,500 mm and outer diameter of 4,000 and thickness of 100 mm. And the lid diameter is 900 mm. So we're going to use this in the cylindrical coordinate formula for the model of the water tank. So the problem is now is how to determine the radius of the cylinder for an inner part. So to solve this problem is we need to refer to the water tank thickness, which is 100 millimeter, and subtract the outer diameter for each side by twice the thickness. And we divide by 2, so then we get the radius of the inner part. The third part is sketch the cylinder in 2D graph XY and 3D graph XYZ. And for this information will be used to develop template integral in cylindrical coordinate volume. So the problem is here now is how to develop the integral equation. So according to the civil engineering mathematics module under the topic triple integral in cylindrical coordinate, we need first is calculate the volume of cylinder and check the answer with normal cylinder volume formula. For the fourth fact, referring to the World Health Organization, who hostel building per head use 90 liters or 3.75 liter per hour. Span state the recommended flow for bulk meter size is 50 millimeter. So the idea is the total daily water usage need to be calculated. So how to calculate the water tank capacity? Time taken for water tank to be filled and total number of people in block D. So we need to calculate the total number of people first, then calculate the time taken, and then calculate water tank capacity. And after all that, we're going to compare the value of water tank capacity with hood information, with liter per head, and analysis the data calculation. And the last fact is ensuring the future demand is met. So we need to design the water tank that is suitable as the population grow. The problem is now how to calculate the population growth in the volume calculation since we don't know how many people will be in the future. So the action plan is we just estimate the population growth and revise the water tank accordingly.
Assalamualaikum and a very good day. My name is Nurul Aida binti Asri. My number matrix is CF220204. So I would like to present about the result and calculation of our project. So our project is focused on solving the water shortage problem that faced by the residents at Block D, Bumbung Biru Taman University. There is many several issues that the water shortage problem, but the main issues identified is possibility that the water tank capacity may not be enough to meet the daily needs of the residents during peak hour. So to solve this problem, we need to check to calculate the exact volume of the water tank using the triple integral method in cylindrical coordinate. This is the specifications of the tank size that we use in this project. The outer diameter is 4,000 millimeters, the thickness is 100 millimeters, the height is 3,500 millimeters, the inner height is 3,100 millimeters, and the inner radius is 2.0 meters. Based on this specification size of the tank, we did not use the actual water tank size from Block D. Instead, we refer to a standard cylindrical water tank size that commonly used in apartment buildings. So this is the calculation that by using triple integrals for the form cylindrical volume for inner part. Using the data and solving the triple integral, we calculate the volume for one tank to be 38.956 cubic meters. Multiply by 2 because the apartment block used 2 water tanks, so we get the total volume which is 77.91 cubic meters. This is the time to fill types of building with the respective liters for 24 hours according to WHO standards and the total residence of one block apartments, determination of water storage capacity. So according to WHO standards, each person use about 90 liters per day. There are 100 residents, so total daily demand is 9,000 liters per day or about 375 liters per hour. Meanwhile, the water filling rate is 1,000 liters per hour and the total tank capacity is much higher than the daily usage. So actually, the tank is more than enough to store and supply water to all residents.
I will continue talking about discussion. So our group have successfully calculated the volume of cylindrical water tank at Bumbung Biru by using the triple integral method in cylindrical coordinates, which is 38.956 meter cube for a tank, which was then verified with the standard cylinder for volume formula, which is pi r square times by height. So we got the same answer. The total storage from two tanks is 77,911 liters. With an inflow rate of 20,000 liters per hour, the tank can be fully filled in approximately 3 hours and 54 minutes. Based on WHO standard, the total water demand for 100 residents is 37 to 375 liters per hour. When compared, the inflow rate is greater than the outflow, confirming that the current tank system is sufficient and meet daily water needs even during peak usage. For conclusion, the triple integral is a mathematical method that is highly useful for calculating volume in three-dimensional space. In this project, the triple integral was applied to accurately determine the volume of a cylindrical water tank. The results show that the current tank capacity of 70,911 liters is more than sufficient to meet the daily water needs of 100 residents, who consume about 375 liters per hour. Therefore, the existing water tank is proven to be effective and able to support demand even during peak hour. However, to prevent water shortage, issues such as leakage, low water pressure, and the quality of construction material should be addressed. Overall, the study successfully achieved its objective of understanding the triple integral concept and determining the required tank volume to support community water needs.
Okay, that's all from our group. Thank you so much for listening. I hope you have a great day. Bye.